So we're going to start off the lesson tonight by going through the frequently made mistakes for assignment 1A. A bunch of things to note. First of all, some people did very well. That's great. Other people struggled quite a bit. Other people, I don't know whether you succeeded or struggled because I haven't seen all the code yet. Some people have not pushed their code in a way I can read it. Some people have not pushed code at all. Other people have pushed code that has no implementation. So make sure that you are correctly providing the information. All I should need to do is just go to a git clone of your repository and then take a look at what you've done. And if I have to go hunting around, that's too much trouble for the review process. So make sure that when I clone your repository, everything is sitting there waiting for it, ready to go. A couple things too, make sure that you run the unit tests. There were lots of solutions that clearly would not have passed the unit tests. So make sure you run the unit tests. They're there to help us, you and me, and anyone else who does any reviews understand whether you're going to be successful in completing the assignment. So make sure you get everything working, and running those tests early and often will be helpful. Also, to make the review process streamlined, please do not remove the to-do tags. So there are to-do tags in the code that you have to fill in. If you start removing them, then I have to search all over the place trying to figure out where you added your code, and it slows things down. So please make sure you don't remove those. And then also, please make sure you submit your assignment on time, and make sure you submit it correctly, and make sure that you make a good faith effort to actually implement the solution. This assignment is really simple. So if you are struggling mightily, then you may be in the wrong course. So this is really just to check to see whether you can write object-oriented Java. The other stuff we're going to be doing later is much more interesting, much more sophisticated, really in the spirit of the parallel functional programming. That's the heart of the course. So make sure that you can do this stuff. And that's why the first two assignments are intentionally designed to be pretty straightforward. So let's talk about some of the problems I saw. First thing, make sure that you read the specifications of the methods carefully. A lot of people are leaving out range checks. They're leaving out sanity checks. They're not throwing exceptions when they should. Those are all things that should be getting caught by the unit test, by the way. So make sure that you check to see whether the initial capacity is greater than or equal to 0, and then throw the specified exception if it's not. Don't assign a value and then immediately reassign it. That doesn't make any sense. So you shouldn't have to do this. You shouldn't have to assign M element data to empty element data. That's what gets done in the default constructor. Likewise, you don't need to do this extra step. You'll see me giving lots of little comments along the way. If you create a local variable whose only purpose is then to be used as an assignment immediately thereafter, that's not doing anybody any good. So avoid that. It doesn't help make the code more readable. Obviously, the optimizer will get rid of it, so you're not helping improve things. For the unsynchronized array constructor that takes a collection, make sure to check to see if the collection is null and throw the appropriate exception. Again, as per the specification, that should be getting caught by the unit tests. You don't need to say the toArray new object size stuff here. You can just do this. And you're missing something important in this case. Something is not being set that should be being set. So I believe that to your discretion to figure out what that is. But again, I think the unit test will probably catch that. Some people were doing extra stuff that didn't need to be there. You don't need to be wrapping the collection in an array list and then saying to array. That's way too many extra levels of indirection for no benefit. And I'm not sure what this is supposed to be doing here, but you don't need this either. So that should go away. Some other similar problems. It doesn't need to be a complicated use of making a list from the collection and then streaming the list to a stream and then turning it to an array and then turning the list into an array. That's like probably 5 extra steps that don't need to be there at all. So try to keep things simple. The unit test probably won't capture that kind of stuff, but that's something that a code inspection will easily capture. Again, there should be no need to use loops. I think in general, there's probably only a need for like one loop in this entire program. And we'll talk about that when we get there. There should be no loops. There should be no while loops. There should be no for each loops with maybe one exception. There should be no index-based for loops. There should be no iterators used in the context of a loop or a while loop or a do loop or whatever. Don't do that. Just use the c.toArray method or c.uncheckedArray, to unchecked array, whatever, a.uncheckedArray. there's various ways to use those things. No need to do things in a way that will be unnecessarily inefficient. Make sure that you're working your magic for stuff like is empty using the M size field. Don't be taking a look at the length of the element data. That doesn't really make any sense. Empty means that you have M size equals 0, not that the length of the array is 0. That doesn't make any sense. Please get in the habit of writing your code more succinctly using Boolean conditions like return M size equals 0, as opposed to if such and such, return true, else such and such, return false. Doesn't make the code any faster. It doesn't really make it any more readable. And in this case, it's actually just incorrect as well, but that's another story. Again, this code is just wildly inefficient. Is empty should be a simple one-liner that checks to see if M size equals 0. I'm not really sure what this code is doing, but it's wildly inefficient and too complicated. It should just be a one-liner. So keep it simple in situations like that. The size method should return M size, which you should keep track of and update. You shouldn't be using M element data dot length -1. I don't know what that means, but that's incorrect. Now, let's talk about index of. Lots of fun things to talk about index of. And there's all kinds of ways to implement this, of course. There's correct ways to implement it that have some deficiencies. There's lots of incorrect ways to implement it. People did a mixture of both. Here's an example of an incorrect way to implement things. This code will basically throw a null pointer exception if M element data sub I is equal to null. So if M element data sub I is null, we'll be trying to call equals on a null reference, and bad things will happen. You get the null pointer exception. So don't do that. Down here, you don't be using get. Get uses range checking. There's no need to use range checking. As long as you do things correctly, things will be in range. By the way, I just think I noticed another mistake here. Don't make the loop run until M element data dot length. You want to do it for M size. That's the valid part of the array, not length, but M size. So don't do that either. So that's another mistake. Don't use get because you shouldn't need it if you do things correctly with M size. Don't have all this complicated stuff here, checking if current element equals null and continuing and then blah, blah, blah. Just swap the order so that you always say O dot equals M element data sub I, because we know that O must be non-null. Otherwise, we wouldn't be in this loop in the first place. And this behavior is incorrect. If O is equal to null, that's perfectly fine. You just have to have another loop there in order to handle that case. So bailing out at -1 is incorrect. And that should also be caught by the unit test as an error. This code is inefficient. This is a comment I gave to a lot of people. And let's kind of talk about this because some people had different points of view. So I'll explain my reasoning. So this code is inefficient because it's doing a check inside the for loop. And there's several issues here to be thought about. Number one, for infrastructure code, like an array that is intended to be used lots of places, getting it to be efficient is probably the most important thing. So that would be one thing. So if you split this up into two loops, one of which handles the case where the parameter O is null and the other handles the case where the parameter O is non-null, then you've gone away from doing O of n checks inside the loop to a simple O of 1 check outside the loops. So it's going to be a little bit more efficient. So it's always good to try to optimize things, especially for situations like that. Secondly, I honestly think that having these if statements in the middle of the loop makes the code more complicated to understand, especially when people did it in ways that led to bugs. So it actually is much easier in my mind to have two loops that each does one thing, and it's easy to tell from inspection whether they're correct rather than having complicated loops, complicated conditional checks inside. Reasonable people could differ on that one, of course, but the performance reason is the real thing that I think gives the motivation for doing this. Moreover, if you take a look at the implementation of index of an array list in Java, you'll see that it does it with two loops. So that's yet another reason to go that way, because obviously the people who implemented Java understood the importance of trying to optimize infrastructure code. Let's now turn our attention to some other methods like add all, which takes a collection and basically goes ahead and appends it to the end of the current collection. So this logic here is unnecessary with checking to see if length is less than M size plus C size. I'm not quite sure what's going on there, but it's overly complicated. This is also way too complicated. All you need to do here is just say C.toArray, and you basically go ahead and put it at the end. You do an array copy and put C.toArray at the end of the current array using the right, after first making sure things are big enough and so on. So this is way too complicated. I'm not sure what it's doing, but it's unnecessarily complicated. Make sure you check to see if C is null before you do anything else. And if it is null, throw the appropriate exception as specified in the documentation, and avoid using for loops. Use the system array copy method here as per the specification. The specification made it very clear to stay away from using loops wherever possible and go with the array copy. Far few, number one, it's probably optimized in the underlying implementation, possibly. And number two, it takes away these sort of off by one errors that plague us when we use loops oftentimes, especially if you use iterators or index-based loops. Here again, please don't use iterator. That's just unnecessary. There's no need for all that. Just use array copy. But when you use array copy, please make sure you pass the right values to array copy. So this is passing in the wrong value as the length here. And that will lead to confusion and chaos. Once again, the unit tests are your friends, so please make sure you use them. Here's another example of something that's way too complicated. It creates a stream and then takes the stream of and concatenates and does toArray. Way too complicated. Just use a.toUnchecked array. Very simple. Here's another example. Way too much extra work. There's no need for this extra allocation. There's no need for this loop. Just use array copy with the appropriate parameters. In particular, use the unchecked toArray method. So I think that's the one you want to use to do that. Let's see, another problem down here. We've got some more complicated code. This doesn't need to be done with streams. Use array copy again. All right, now let's get in here to some other problems. I don't even know what this is trying to do, but the get operation is just trying to read the value that's at the indexed location, assuming that index is within the range of the valid range of the loop. So range check, of course, has to be implemented correctly, but assuming that it is, then all you need to do is just return the item at that location. Using a loop makes no sense at all. So don't do that. That's way too inefficient. I'm not even sure if it works correctly. Similar problem here with the set method. I'm not sure what's going on, but it's way too complicated. And all you need to do is just set the item at the index location to element, assuming that index is in range. Another problem here, you don't need to be making backup copies of anything, just set the element. I'm not sure what's going on here, but if we do a range check and then we later find out that the index is greater than M size, something is seriously wrong with the range check method. So throwing that exception is sort of a belts and suspenders, an unnecessary belts and suspenders approach. This is a niggling little point, just good habit to get into, to say, M size plus plus or plus plus M size as opposed to M size plus equal 1. Yes, of course, they mean the same thing. Yes, of course, the optimizer will turn them into the same, bytecode or whatever is used to compile this into the execution engine that runs your Java. But an experienced programmer will be confused when you say M size plus equal 1. They'll start going, what are they trying to do here? So keep it simple and use the conventional approaches. A lot of issues with remove. You don't need to clone anything. Not sure what that's trying to do, but it's not the right thing to do. And we don't need to be making a new array. So you just have to use array copy and slide everything down by 1, but only if you have to. We'll talk about that. This approach was pretty clever, I have to say. I hadn't thought about it. So it was a novel approach, but I think it's probably much more efficient to just use array copy. You'll just slide everything down by 1. So give an A for creative approaches, but it's probably not the most efficient way to do things. Don't use a for each loop here. I'm not really sure what this is doing, but it's way too complicated. So keep it simple. You don't need to have any loops again in this part of the code. Don't need to make a backup of anything. You don't need to do all this extra work. You just need to slide everything down by one if necessary. And we'll talk about that. And you don't need to make copies of anything. You don't need to making a for loop, use array copies. So I think I'm sort of repeating myself, but people came up with lots of clever ways of making it much more complicated than it need to be. And then another little tidbit to remember, if you're removing the very last element in the array, you don't need to slide everything down. So that's a good optimization to make. If you're taking the last element off, you just have to decrement the size by one and go ahead and set the value to null or whatever, so the garbage collector will clean it up. But you don't need to be doing any sliding in that case. Let's talk about ensure capacity internal. This implementation is very incomplete and doesn't implement the specification. It only does anything if the element data is empty, but it won't handle the other cases. So that's clearly deficient. The unit test should catch that. This code is very inefficient. And one thing you want to do is you want to avoid just incrementing it by min capacity, because if that happens, if you add things successively one at a time, you'll keep regrowing the array by one over and over and over again, which is very inefficient. So you want to actually do something more optimized, like double the size each time, which means you'll only ever do log n reallocations, which is nice, even though you might waste a little bit of memory at the end. Let's talk about the iterator. You definitely don't want to be doing this. This is way too complicated. I mean, it's kind of clever, but just make yourself a new instance of array iterator. You don't have to make a stream of the element data. I don't even think that's correct, because the element data isn't sized properly for what you're trying to do. So I don't think you want to do that. Again, here's a little style tip. There's no sense in creating a local variable whose only purpose is then to be returned. Just go ahead and return the newly allocated array iterator, much cleaner. Please don't put all your code as an anonymous inner class here in the iterator. Instead, make an instance of array iterator, and then make sure you implement array iterator to implement the has next and remove methods. Okay, a lot of issues here. This is the sort of the one and only place you should use a for loop, use a for each loop. And this implementation isn't necessarily wrong, but save that for upcoming assignments like assignment 1B. Go take a look at this video here, and you can slide ahead to minute 2:58, and you will see how this works. And it's a really cool technique. So I won't spoil it for you, but go take a look there. Likewise, this code is incorrect. It's looping through the element data, but that's not the right thing to do. You don't want to be looping through the element data. You want it to create an iterator and then iterate through it. So you'll see if you watch the video how to do that. It's really cool. Another sort of stylistic point, just get in the habit of saying return conditional expression, return current position less than m size. That's much more concise than if current position less than m size, return true, else return false. Just more verbose than it needs to be. This implementation of next was curious. I didn't know why next was being called, and then it was being called again. I mean, I knew why it was being called the first time to see if it was going to trigger an exception, but store the value and return it if you don't get an exception. So you don't want to call it twice. That's overkill. Here's some other issues. This code needs to be modified, and it needs to make sure that it, well, I take it back. This code may actually not be incorrect. I think that actually is okay. It's checking here. So let me get rid of that particular response. That was okay. That was fine. I didn't understand calling the iterator method here, but it's very complicated and unnecessarily complicated. I'm not sure what it's trying to do, in fact, because it's trying to implement the next method by calling iterator next, which didn't make any sense. It's probably an infinite recursion call. And there's a bunch of issues people had with the remove method. So what you really want to do is you want to remove the item using the remove method that's defined in your unsynchronized array. And this will not do that. It won't slide things down. This is way too complicated. Again, just use the remove method that's defined in unsynchronized array. I think you can get to it by unsynchronized array this.remove, and then whatever you're giving here is the parameter. Again, another problem, way too complicated. Let the remove method do this for you. That's what it's there for. It's a good example of code reuse. And then finally, here's a remove implementation. that is a little too sparse. It doesn't take into account what the specification says about throwing an exception under certain circumstances. It doesn't keep track of, it doesn't update the fact that you've removed an item already, so you can incorrectly remove something multiple times. So those are the common problems I've seen in all the frequently made mistakes analysis I've done for the versions of assignment 1A that I've reviewed. If you were unable to submit your assignments, I won't review them at this point. It's well past the deadline, but you can watch the video that I'll put out. I'll make a standalone video of this, or you can just go back and watch this in the class video. And that way you can see what other people made as mistakes, and hopefully that will help you do a better job of avoiding those mistakes in your code.